Okay, so here is where you can check your work. You'll notice that the graph over here is marked up like crazy. That's because that's how I literally have to do it. I trace my pencil, I look for key points, and slowly but surely just go along for the ride. On number 2, the thing I want to mention are these 2 open dots right here and how that affects my domain, because actually at the point x equals 1, there is no value. Your function does not exist when x equals 1. Here we've got problem number 3. You'll notice that I did not include a maximum and a minimum here. That's because we actually have kind of this issue because it's 2, but it's not really 2. And then we've got no minimum because it keeps on going. Kind of your standard issues here. So what you would want to do at a problem like this is you would name each of them. You would name this one as a local minimum, okay, local, local, and you would just do the best that you can there. So now let's move on to some more additional practice. So here it says go to desmos.com on your Chromebook or on your phone and type in these functions and graph them to see if you can identify the characteristics. What I would like you to do instead is use your transformations of functions to graph these things. Okay, there's a reason that we've been doing it that way. Is this, again, that, if you remember, is your slope, while this is your y-intercept. So this graph is going to start at -1 right here, and then it's going to go up 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3. And then we're going to connect our dots. Okay? So you could have gone to desmos.com, you could have typed it out, you could have built a table, but if you remember your characteristics and your transformations, you'll be much better off. So what kind of graph is this? This is linear. Linear graphs have a domain of all real numbers and a range of all real numbers. So is this graph increasing, decreasing, or constant? So this is all based off of which direction you're moving. So this one, if I were to go left to right, this would definitely be an increasing because you're going up. Okay, notice now in this next graph, we have a slope of up 3 over 2 with a starting point of +1. So 1, 2, 3 over 2, 1, 2, 1, 2, 3 over 2, yay! Wait, is that right? 1, 2, 3 over 2, that doesn't look straight. 1, 2, 3 over 2. Maybe my eyes are just playing tricks on me. Okay, so there's my graph. Again, this one's linear, and linear has a domain of all real numbers. This one asks you for the y-intercept, which is this point right here. So your y-intercept would be 0, +1. Now, would this one be either odd or neither? This one would actually be neither because you can't split it down here, and you can't rotate it perfectly through the origin. The last one, here's our quadratic transformations that we've been working on. So remember our parent function would be 0, 0, 1, 1, okay, 2, 4, 1, 2, 3, 4. Okay, and we're going to just transform it from there so that we don't even have to use a graphing calculator. So that +1 in the middle means that we are going to the left by 1 unit. So I'm going to take those original purple dots and I'm going to move them to the left by 1. Okay, the +4 means I'm going up 4. So I'm going to take my red dots and now move them up 4. Notice this one's going to now go off the graph. Whoops. Okay, this one's going to go up 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. So all I have are these 3 dots right here, but that's okay. Because then the last thing I'm going to do is scale it. So right now this would go over 1, up 1, but this is telling me that I'm going to go over 1, down 3. So final color change here, let's do pink. We're going to go over 1, so this is still my vertex, over 1, down 3, 1, 2, 3. Over 1, down 3, 1, 2, 3. Okay, and there's my graph. Okay. So this is quadratic because I have an x squared. The range would be from positive 4, it looks like, so negative infinity to positive 4. How many x-intercepts do you have? 2. Why is it 2? Because it's quadratic. Okay, your increasing interval is from negative infinity until negative 1, because that's where my graph is going up. Okay, so go ahead and pause this video now and continue to do the other ones. You'll notice down here, these, please use Desmos. We haven't done anything like that. And then copy those graphs. Okay, we should be ready to move on now. So let's quick, you know what? This one's not even going to fit on our graph. So let's walk through this one because we know it's quadratic. Okay, the domain is going to be all real numbers. And let's talk about the decreasing interval. I know it's going to be way down here because that negative 16 tells me to go down. So the decreasing interval is going to be from 0 to positive infinity. So the x-intercepts, are you going to have any x-intercepts if your entire graph has been moved down by 16? Yeah, you will. They're just somewhere we don't know. So remember to find your x-intercepts. You set your equation equal to 0 and solve. So I'm going to add 16 to both sides. I get x squared equals 16. Takes the square root. So x equals positive or negative 4. So you've got negative 4 and 0, and then positive 4 and 0. Okay. All right, let's go on to our next segment. So this segment here, this is actually a review because this was the area of last test that I did not feel like very many of you excelled on. Not because you aren't capable, but it's because the instructions weren't super explicit and I think that you could do better. So what are zeros? When you're talking about graphically, zeros are the points at which the graph crosses the x-axis. Algebraically, it's the points where f of x is equal to 0. They're also called, if you think back to Unit 4, they're also called roots, x-intercepts, and solutions. They all mean the exact same thing. And this can be applied whether you are doing quadratics or anything at all. So if you are identifying a graph or identifying the zeros from a graph, it is literally just a picture finding game. You always look on the x-axis and you say, where is my graph touching it? Right there. So that is your x-intercept. So your x-intercept is 2, 0. It's when x equals 2, y equals 0. And you do the same thing for all of these. Okay, x-intercept, x-intercept. So 1, 0. Let me write it off to the side. 1, 0, and negative 2, 0. Okay, here, that's kind of tricky to read right there. So 3, 0. Okay, they can be applied. They're all these points right here. I'm just going to start marking them. Okay, but they're all these points right here. 1, 2, 3. So everywhere that graph crosses. So how do you find them algebraically? So what if you don't have a graph, or maybe you can't find them on your graph, or what if they are in between your two numbers and you're not quite sure what fraction it is? So step 1, set the equation equal to 0. Step 2, solve for x. And that might look differently depending on which type of equation I've given you. Okay? So all of these examples right here are all linear functions, but this gets you into the habit of what you're doing. So if I'm asking you for the x-intercepts, I'm making this equal to 0, and now I'm solving for x. So I'm going to add 8. 8 equals 4x, divide by 4. So where's my x-intercept? It's at 2. Go ahead and pause the video, do the rest. You should have gotten -1, +7. I'm going to show my work on this one a little bit more just because I know people freak out at fractions. So I'm going to add 6. And then even though it's a fraction, that's fine. I'm still going to divide by that fraction. You got a calculator, should be no big deal. So you've got x equals 9. For number 11, you have x equals -4. Number 12, x equals 10. You can also do these using a graphing calculator, but all of these are quadratic functions. So while you can use a graphing calculator, let's practice solving these quadratic functions for the zeros. So you can do all of these except for number 19, 20, 21, and 22. Those we don't know how to solve yet, but those, if you want to do them, you can do them in Desmos. So for number 13, we're going to set this equal to 0, and this is actually the example problem that we did on the front of the paper here. So we get 0 equals x squared minus 16. So we're going to add 16 to both sides. 16 equals x squared. Take the square root. So x equals positive or -4. That's solving using the square root. Remember, I can only use that one when I have an x squared and nothing else. Okay, let's do another one where we have to factor. So if we look at number 14 here, I'm going to set it equal to 0. And the first thing I notice is how obnoxious that 5 is out front. Is that a GCF? Can I divide by it? You bet. So then we get x squared plus x minus 6. And now I can factor. So what multiplies to 6 and adds to 1? That would be +3 and -2. So then the squares are a little bit small over here, but that's okay. We got x plus 3 equals 0. So x equals -3. And then we have x minus 2 equals 0. So x equals 2. Okay, all of these here can be factored. Be sure that if you have a negative out front that you're dividing by -1 to act as your GCF. So go ahead and pause the video and continue to do those problems. If you did go on to Desmos and graph these more complex ones, you would have gotten that x equals -1, 2, and 4, x equals -1, 0, and 1, x equals -5, 0, and 3, and x equals -5, -2, 0, and 5. This is another good point to remind you of the fundamental theorem of algebra that tells you if you have x squared that you have 2 solutions. When you have x cubed, you have 3 solutions. And when you have x to the 4th, you have 4 solutions. Okay, and that is the end of our notes for day 2. So please go on to Math Excel and complete your practice problems.